Hey friends, this is the second video of my YouTube lecture series Neet 2018 where we discuss OBS and Gynae questions from the latest Neet paper. Today we'll discuss 4 questions in the next 20 minutes. There is this one question which I'm sure most of you must have marked incorrect because most of you don't know what this term pre-implantation genetic diagnosis actually means. Now the question says, which is an indication for pre-implantation genetic diagnosis? Now you have to know that there are two similar terms, pre-implantation genetic diagnosis and pre-implantation genetic screening. So this question was basically the difference between diagnosis and screening. Another important aspect that I want you to know is that this test is similar to the principle, or rather the indication is similar to prenatal testing. Prenatal testing is an important topic for the exams these days. Prenatal diagnosis techniques like prenatal testing, which again includes prenatal screening and prenatal diagnosis. These tests include the triple test, quadruple test, nuchal translucency, ultrasonography, and then you have diagnostic techniques like chorionic villus sampling, and you have amniocentesis. So all these are prenatal diagnostic techniques. When you do the diagnosis, even before these are done after conception, when the baby is at least 11 weeks of age. 11 weeks of gestation. But when you do the same tests, you want to detect the same conditions, rule out the same conditions even before implantation of the embryo, then it is called pre-implantation genetic diagnosis. Now, to be able to obtain cells from the embryo before implantation, you have to do assisted reproductive techniques or artificial reproductive techniques. You cannot allow natural conception and then extract cells from the embryo before implantation. You can only do it with assisted reproductive technique. Assisted reproductive techniques are those reproductive procedures in which oocyte is manipulated outside the body. That is, you extract oocyte from the female, you take the male's spermatocytes, you fertilize an oocyte with spermatocyte in the laboratory. You do 2 or 3 or more than that oocytes are actually fertilized with spermatocytes in the laboratory to form embryos, and these embryos at the proper stage of development are implanted into the uterus. That is ART. In this same procedure of ART, what I will do is, before implanting the embryo say it is a 16 cell or whatever number of cells are there in the embryo at whatever age, at whatever stage of development it is, before implanting I will take a cell out from here and I will run my genetic tests on this to know whether the embryo is suffering, whether the embryo has the genetic condition which runs in the family or not. So I actually made 4 embryos out of in vitro fertilization in the lab, and then I took one cell from each of these embryos and I ran my genetic testings on them. Whichever embryo did not have the disease was used for implantation. So you are at least assured that the embryo most probably does not have the condition, right? So those techniques are called pre-implantation genetic diagnostic techniques. An important aspect of this is that you don't have to wait for conception actually to take place, and you don't have to abort a baby which is already implanted. You can do it before implantation. The couple doesn't have to go through conception and then abortion. It is done much before conception actually takes place. So pre-implantation genetic diagnosis is an early form of prenatal diagnosis. So this is a mixture of the technique is through ART, artificial or assisted reproductive techniques, and basically the indication is prenatal diagnosis done even before implantation. So the name is pre-implantation genetic diagnosis. Now, the most important part of the definition is that it is done for couples at risk of transmitting a genetic disorder. That's the difference between diagnosis and screening. When you already have a couple who suffers from a particular genetic condition or who are carriers of a particular genetic condition, there's a high risk, high possibility that the offsprings will also have the same genetic condition. So when you are looking for those particular genetic conditions, when you're looking for those particular mutations in the embryo, you call it pre-implantation genetic diagnosis. And the difference between screening and diagnosis is that for screening, you're not looking for a particular genetic abnormality. The female or the couple is at high risk of having an abnormal baby or has had multiple abortions in the past, and you want to select the healthiest embryo for implanting for better fertility outcomes, better implantation. That is called screening. When you're not looking for a particular genetic abnormality, you're screening the entire chromosome for possibility of any aneuploidy which could harm the baby or which could harm the conception. That is screening, right? So genetic methods that you use for diagnosis and screening are a bit different, because in diagnosis we just have to look at a particular gene. The couple is interested only in knowing whether, suppose the couple suffers from cystic fibrosis, or both of them are carriers of cystic fibrosis or any other autosomal recessive condition, and then there is 25% chance that the baby could have the disease. So they just want to know whether the embryo you're implanting has cystic fibrosis or not. So for that, the tests that are used are different. The principles for the test used is different. PCR, FISH, microarray, CGH and karyomapping, all these can be used for that single genetic defect that you're looking for. Now, indications for PGD are genetic diseases in the family. Monogenic, which should be autosomal recessive, dominant, X-linked or Y-linked. Chromosomal abnormalities. Suppose there's a couple with recurrent pregnancy loss. You did karyotyping in both husband and wife, and they were carriers of balanced translocation. Now, it is known with balanced translocations that the person actually carrying balanced translocation does not have major phenotypic effects of the translocation, because it is balanced. But in reproduction, during meiosis and then fertilization, the translocation becomes unbalanced, and then there is increased risk of recurrent of the loss of such pregnancies, because unbalanced translocation does not form a viable fetus, or there is a high risk of aneuploidy in such fetuses. So balanced translocation, though phenotypically does not confer any abnormality, it is a risk for recurrent pregnancy loss. So you have a couple who had RPL and they are proved carriers of balanced translocation, and you're looking for that particular translocation, unbalanced translocation in the fetus or embryo before implantation. It is also an indication for PGD. Then mitochondrial disorders, or complex inherited diseases. So all of these are specific conditions that we want to look for. Such tests are called tests for prenatal genetic diagnosis. Another important indication for PGD is HLA typing. Now suppose in the family they already have a baby who has a major condition like leukemia or thalassemia and requires stem cell transplant and doesn't have any matching HLA donor. So what you do is you call the couple, you do an IVF, you get 3 or 4 embryos, out of which you're going to select the embryo which is HLA matched with the baby they already have, with the baby who needs stem cell transplant. So this other baby after 9 months will become a stem cell donor for your baby which you already have, who needs stem cell donation for the medical condition the baby is suffering from. So this here also you're looking for a particular genetic makeup. You're looking at the genes that encode for HLA on the chromosome 6. That's why it is an indication for PGD. Now coming to prenatal genetic screening. This I think we have already discussed. I have been repeatedly calling it prenatal. It is actually pre-implantation that we are discussing here. It is before conception. So pre-implantation genetic screening applies to the same technology, but here the couple does not have any known chromosomal or genetic abnormality. Here you're just screening the entire chromosome. Here also we use FISH or CGH. But we are not just testing a single gene, we are screening the entire chromosome with FISH. FISH will tell you about a few aneuploidies like 16, 18, 21, 13, all those things, and CGH will screen the entire chromosome. Comparative genomic hybridization. PGS aims to identify and exclude aneuploid embryos. In couples who are at increased risk of having aneuploid babies. Like in older women, those with history of recurrent miscarriage. Now here, there's a history of RPL, but there's no proved reciprocal or Robertsonian balance translocation. And then in women with repeated unexplained IVF failures, you do PGS. So when you're not looking for a particular genetic abnormality. Now come back to the question. I hope now the question is easier. Which of the following is an indication for pre-implantation genetic diagnosis? Advanced age is not. It is a indication for PGS. Single gene disorder. Yes, that's the answer. Aneuploidy risk. Again, it's an indication for PGS. They have not mentioned a specific aneuploidy. So it is PGS. Recurrent abortions, PGS. Understood? Now coming to the next question, which is also on ART. Now this question again is very important. Includes two important topics, ART and twins. Now twins are of two kinds. You have monozygotic twins and dizygotic twins. When a single spermatocyte fertilizes a single oocyte and you have a single zygote which at a particular stage of development divides into two zygotes, it is called monozygotic. Mono because both the zygotes, both the babies are going to have similar genetic makeup. That is monozygotic twinning or identical twins, as you say. Dizygotic twins is you have two oocytes either from two different ovaries or from the same ovary, and then you have two different spermatocytes fertilizing them. So the genetic makeup of both these embryos is completely different. They are only temporally related. They get implanted in the uterus almost at the same time. They are completely two different individuals with two different genetic makeup. Now such dizygotic twins are usually always dichorionic and diamniotic. Right. While monozygotic can have various combinations of chorionic sharing and amniotic sharing based on which period of gestation the embryo actually divides. Now dizygotic twinning, that is two oocytes being fertilized by two spermatocytes, has various risk factors associated. Like there's a race, heredity, maternal age. Increasing maternal age increases the risk, increased parity, nutrition, conception immediately after stopping a COC, infertility therapy, any kind of infertility therapy, whether be it ovulation induction. Ovulation induction is we give drugs to the female to cause induction of ovulation. Sometimes this leads to multifollicular development. Two or more oocytes may form at the same time, and then you may have increased risk of, now when you have two oocytes, the risk is increased of dizygotic twinning. Similarly, when I do artificial reproductive techniques, generally we implant one or more than one embryo. When you implant more than one embryo, two embryos or three embryos, there's a risk that all of these embryos will get implanted and you will have a twin pregnancy. Now basically we implant two or three embryos only to have a advantage that if one of the embryos is lost, at least the other one will implant. So most of the cases, if one of them is not lost and all the embryos get implanted, you have multiple pregnancies. So any kind of infertility therapy, be it ovulation induction or be it artificial or assisted reproductive techniques, you have increased risk of multiple pregnancies. Most commonly, the type of multiple pregnancy is dizygotic or trizygotic because the principle is multifollicular development. Multiple oocytes will form and you will have multiple babies. So these twins are dizygotic most commonly. Monozygotic pregnancies, monozygotic twinning on the other hand is more or less constant at the rate of 1 per 250 births as mentioned in the books. It is largely independent of race, heredity, age and parity. So it is a random event occurring at around the rate of 1:250 births. But ART does increase the risk of monozygotic twinning as well. Now the principle of ART increasing the risk of dizygotic twinning is simple. Now they say ART and the relative risk of having dizygotic twinning is higher. So most common type of twinning associated with ART is always dizygotic, because you have multifollicular development. Another thing is, when you do ART, you actually manipulate the embryo in the lab. Now because of this manipulation, there might be some injury to the embryo and it might divide inside, and also this may increase the risk of monozygotic twinning. So ART is also associated with increased risk of monozygotic twinning. Now, since the question has various types of monozygotic twins, I thought we will discuss this also. What are the types of monozygotic twins that you can have? If you remember, I've already told you the dizygotic twins are most often going to be dichorionic amniotic. That is, they have two separate placentas and they have two separate amniotic sacs. While a monozygotic pregnancy, that is a pregnancy which is divided from a single morula or a single embryo, it can have various levels of division. If it divides before any differentiation, like it is just at the morula stage, a bunch of cells are there and they simply divide. They form two completely different individuals with different placentas and different amniotic sacs. It is called dichorionic diamniotic pregnancy. You have different placentas and you have different amniotic sacs. Then you have monochorionic. Here what happens is trophoblast has already differentiated. Trophoblast is going to form placenta. So the placenta that forms is single and you have two babies in two different amniotic sacs. This is when the division takes place between day 4 to day 8 after fertilization. Then if the division takes place after day 8, after differentiation of amnion, you have monochorionic monoamniotic pregnancy. Twin pregnancy, you have a single placenta, single amniotic sac, and you have two babies inside the same sac. There's no sac dividing them. This is monochorionic monoamniotic. Conjointers, further after day 13, if a division takes place, the babies might be jointed to various places. And incompleters, the body is single while there are two heads, or you can have multiple limbs like dicephalus, etc. Then the answer is simple here. ART is most commonly associated with, it is not monozygotic, it is not monochorionic, monoamniotic, it is not conjoined. All of these are mostly monozygotics. Only dizygotic is the answer here. Now coming to the next question. Again, the question is on twins. Best period of gestation for ultrasonography determination of chorionicity. Now, if you see this table, dichorionic diamniotic and monochorionic monoamniotic on ultrasonography look similar and are difficult to differentiate. Well, this is easy to diagnose. You have a single placenta, you have no membrane in between. So this is a different story. It is always difficult to differentiate between two placentas and one placenta. To differentiate between single amniotic sac and double amniotic sac is easy. You see the amniotic sac. If you don't see it, it is not there. So this is easy to diagnose, monochorionic monoamniosity. What is difficult to diagnose is chorionicity of the fetus. How many chorions it have? How many chorions it has? Dichorionic diamniotic. The test that we do on ultrasound, rather the signs which are present on ultrasound are lambda sign and T sign. The best time to define chorionicity is earlier in pregnancy. At 8-12 weeks, what you'll have the placentas will be smaller and the sacs will be thicker. There will be still distance between these two sacs and the placenta. So it is always better to diagnose, better to evaluate twins, chorionicity of twins at earlier gestation. Now let's see how we differentiate between dichorionic and monochorionic. We'll come to this later. We'll first see the signs. Now see, as I said, if you have two separate placentas and you have two separate amniotic sacs, the tissue in between this forms lambda. That's called lambda sign. Right, this lambda sign is indicative of dichorionic twins. Now if it is dichorionic, it is always going to be diamniotic. While T sign, when you have a single placenta and you have only the amniotic membrane in between, you have this sign which is called the T sign. This is T sign and this is the lambda sign. See, as you can see here, that's your lambda sign. This indicates dichorionic twin pregnancy, and that's your T sign. Placenta at the interface between placenta and the amniotic membranes. This differentiates between dichorionic and monochorionic twin pregnancies, and it can be best done at 11 to 13 weeks. Now we advise twins to get an ultrasound done between 10 and 13 weeks, because at the same time you can also look for nuchal translucency and you can date the pregnancy. So the best time to do ultrasonographic determination of chorionicity in twins is 10 to 13 plus 6 weeks. This is the time of first trimester aneuploidy screening as well. So you do nuchal translucency as well at the same scan. The answer here is 8 to 12 weeks. The later in pregnancy, the thinner the amniotic membrane will get, and less easy it will be to differentiate between dichorionic and diamniotic twin pregnancies. The last question, what is superfecundation? Now there are two terms again, superfecundation and superfetation. The difference between these, superfecundation and superfetation, is the basic fact is that one embryo has already formed, one oocyte has been fertilized by a sperm, and it has already started to grow, it has already implanted. Right, if after this another oocyte is fertilized at a separate act of coitus and after a few days it implants in the uterus, it is called superfecundation or superfetation. Whether it will be called superfecundation or it will be called superfetation depends on what is the difference period between the implantation of these two embryos. Superfecundation is fertilization of two ova within the same menstrual cycle, like first got fertilized and implanted at the first act of coitus, and at the same time a few days later or maybe some hours later a second oocyte came which was fertilized by a second act of coitus. That is superfecundation, but this whole thing occurs in the same menstrual cycle, so that there's not a difference of more than 28 days between the babies, implantation of two babies. It is called superfecundation. The second is superfetation, when the interval is as long as one menstrual cycle. Now this is not seen in human beings, it is only seen in animals. Superfetation, theoretically, before the uterine cavity has got obliterated with the baby, you have space for implantation of another oocyte. That is superfetation. There's a difference of at least one menstrual cycle. Superfetation is not known to occur spontaneously in human beings. So your answer here is fertilization of two ova within the same menstrual cycle at separate acts of coitus. Let us see the other options. Two ova within consecutive menstrual cycle, this is superfetation. Fertilization of one ovum by two different spermatozoa, this rather leads to molar pregnancy. Fertilization of two ova by two spermatozoa in the same act of coitus, this will simply lead to dizygotic twinning. I think that is all for today. Thank you. Please subscribe and please share the video. Thanking you for that too if you're doing that.